acceleration on the projectile. We know that acceleration due to gravity acts on the projectile. This acceleration due to gravity will be in the vertically downward direction. But generally we consider the upward direction u sin theta, upward direction O to y is considered as positive while studying the projectile. So we have to consider the acceleration in the vertical direction as downwards. So A will be considered equal to minus g. Acceleration of the projectile in the vertical direction will be taken as minus g since we take upward direction as positive. The component of this acceleration in the horizontal direction is 0. The component in the horizontal direction is g cos 90. G cos 90, but cos 90 is 0. Hence, the component of acceleration due to gravity along the x-axis direction is 0. So, while studying the projectile motion, we take minus g as acceleration in the upward direction and 0 in the horizontal direction. Along y-axis, it is minus g. Along x-axis, it is 0. Displacement of the projectile at P and Q. To understand the displacement of a projectile, let us select 2 points P and Q. At P, OA is x component and AP is y component. So OP is the displacement. The displacement is OP. It is composed of 2 components OA and AP, x component and y component. When the projectile is at Q, it will have 2 components OB and BQ. OB and BQ. So the resultant displacement will be OQ. Actual displacement is OQ. It is composed of 2 components OB and BQ. Like this, we have to understand the displacement of the projectile. Application of equations of motion. Let us apply the equations of motion, kinematic equations of motion in the vertical direction. In the vertical direction, let us take the relations v is equal to u plus at and s is equal to ut plus half at square. In the vertical direction, initial velocity uy is equal to u sin theta. Acceleration a is equal to minus g. And let us say displacement in time t is equal to y. So s is equal to y when t is equal to t. And v is equal to vy when t is equal to t. Then in the relation v is equal to u plus at, substitute u sin theta for u and a as minus g, then we will get vy is equal to u sin theta minus gt. Vy is equal to u sin theta minus gt. With this relation, we can calculate the vertical component or y component of the velocity of the projectile after a time t. Similarly, we can determine the vertical displacement or displacement along y-axis. This is obtained from the relation s is equal to ut plus half at square, where y is equal to, s is taken as y, is equal to u sin theta into t minus half gt square. With this relation, we calculate the y component of displacement. Application of equations of motion in the horizontal direction, that is along x-axis. Let us calculate velocity after a time t and displacement after a time t. In the horizontal direction, initial velocity ux is equal to u cos theta, acceleration a is equal to 0, displacement s is equal to x after a time t is equal to t, and velocity is vx. Displacement is x, and initial velocity ux is equal to u cos theta, acceleration a is equal to 0. So from the relation v is equal to u plus at, we will get vx is equal to u cos theta. Since a is 0, at becomes 0. So vx is equal to u cos theta. The displacement along x-axis. To find the displacement along x-axis, let us take the relation s is equal to ut plus half at square. S is equal to ut plus half at square. So x is equal to u cos theta into t. Because a is 0, half at square becomes 0. So x is equal to u cos theta into t. So these are the relations for finding the displacement and velocity along x-axis. Vx is equal to u cos theta and displacement x is equal to u cos theta into t. Equation of trajectory. Trajectory is the path followed by a projectile. Trajectory is the path followed by a projectile. Let us find its equation. To find the equation, we have to eliminate time from x and y to obtain a relation between x and y, between x coordinate and y coordinate. The displacement along x-axis, x is equal to u cos theta into t. Therefore, t is equal to x by u cos theta. The displacement along y-axis is given by y is equal to u sin theta t minus half gt square. U sin theta t minus half gt square. Let us substitute the value of t from the relation t is equal to x by u. From the relation t is equal to x by u cos theta, we will get y is equal to u sin theta into x by u cos theta, u sin theta into x by u cos theta minus half g into x by u cos theta whole square minus half g into x by u cos theta whole square. So y is equal to x into sin theta by cos theta is tan theta, u gets cancelled. So we will get x tan theta, y is equal to x tan theta minus half g x square by u square cos square theta or minus gx square by 2u square cos square theta minus gx square by 2u square cos square theta. So the relation is y is equal to x tan theta minus gx square by 2u square cos square theta. This is like the equation y is equal to ax minus bx square, which is the equation of a parabola, which we learned in mathematics. In mathematics, we learned that the equation of a parabola is given by y is equal to ax minus bx square. This is one of the forms. Here, if we compare these two relations, we get a is equal to tan theta, the constants a is equal to tan theta and constant b is equal to g divided by 2u square cos square theta. B is equal to g by 2u square cos square theta. So, g by 2u square cos square theta is constant and tan theta is constant for a given angle of projection and velocity of projection. So, we will get the equation y is equal to x tan theta minus gx square by 2s square cos square theta is similar to the equation y is equal to ax minus bx square, where a and b are constants. So, since y is equal to ax minus bx square represents the equation of a parabola, so y is equal to x tan theta minus gx square by 2u square cos square theta will also represent a parabola. Y is equal to x tan theta minus gx square by 2u square cos square theta represents the equation of a parabola. Hence, the path of or the trajectory of a projectile is a parabola. The trajectory of a projectile is a parabola, or the path of a projectile is a parabola. Summary of what we have learned so far. We have taken a projectile described with initial velocity u and angle of projection theta. We resolved this velocity into two components, u cos theta along x-axis and u sin theta along y-axis. And we have taken the equations of motion v is equal to u plus at and s is equal to ut plus half at square. And the initial velocity is represented by ux, which is u cos theta along x-axis, and along y-axis uy is equal to u sin theta. And then we determine the velocities along x-axis and y-axis after a time t. We obtain the velocity along x-axis is a constant, which is u cos theta. Along y-axis, the velocity is vy, which is equal to u sin theta minus gt. U sin theta minus gt. And the displacement of the projectile along x-axis is oa, that is given by x is equal to u cos theta into t. And the displacement along y-axis is ap, which is equal to y, and it is equal to u sin theta t minus half gt square. Like this, we determine the displacements and velocities along x and y axis. Derivation of equation of trajectory. We have taken displacement along x-axis, which is given by x is equal to u cos theta into t. From this, t is equal to x by u cos theta. We have substituted this value of t in the equation y is equal to u sin theta t minus half gt square, which is the displacement along y-axis. By substitution, we get y is equal to u sin theta into x by u cos theta minus half g into x by u cos theta whole square. By simplification, the first term becomes x tan theta and the second term becomes gx square by 2u square cos square theta. Hence, y is equal to x tan theta minus gx square by 2u square cos square theta. By comparing this with y is equal to ax minus bx square, where a and b are constants, a is tan theta, a constant, b is g by 2u square cos square theta is also constant. Hence, this relation y is equal to x tan theta minus gx square by 2u square cos square theta represents the equation of a parabola. Maximum height. Maximum height. It is the vertical height attained. It is the vertical height attained by a projectile. By a projectile from the plane of projection. From the plane of projection where its vertical component of velocity is 0. From the plane of projection where the vertical component of its velocity is 0, but it will have horizontal component of velocity. So the total velocity is not 0, only the vertical component of velocity is 0. Such a height from the plane of projection is called maximum height. Maximum height. We have taken uy is equal to u sin theta, a is equal to minus g, vy is equal to 0, s is equal to capital H. Let us substitute these values in the relation v square minus u square is equal to 2as. V square minus u square is equal to 2as. By substitution, we will get vy square minus uy square is equal to 2as, where s is capital H. Vy is 0. So 0 square minus u sin theta whole square is equal to 2 into minus g into capital H. 0 square minus u sin theta whole square is equal to 2 into minus g into capital H. Or 2g capital H is equal to u square sin square theta. 2g h is equal to u square sin square theta. Or capital H is equal to u square sin square theta by 2g. Capital H is equal to u square sin square theta by 2g. This is the relation for maximum height of a projectile. Time of ascent. The time taken to reach the maximum height is called time of ascent. For finding time of ascent also, it is enough if we consider the vertical motion of the projectile. Initial velocity uy is equal to u sin theta, a is equal to minus g, time of ascent t is equal to ta, and velocity at maximum height is 0, vy is equal to 0. Uy is equal to u sin theta, a is equal to minus g, vy is equal to 0, t is equal to ta. Let us substitute these values in the relation v is equal to u plus at. Let us substitute these values in the relation v is equal to u plus at. 0 is equal to u sin theta minus g into ta. 0 is equal to u sin theta minus g into ta. Or g into ta is equal to u sin theta, g into ta is equal to u sin theta, or ta is equal to u sin theta by g. ta is equal to u sin theta by g. Time of descent. Time of descent. It is the time taken by the projectile to reach the ground from maximum height. The descending time is known as time of descent. The time taken from maximum height to the ground is known as time of descent. For this purpose, we consider the vertical motion of the projectile. We consider its initial velocity as 0 because at maximum height its vertical component of velocity is 0. So we consider it as a freely falling body, and acceleration a is equal to g, s is equal to maximum height, which is equal to h is equal to u square sin square theta by 2g, and we want time of descent t is equal to td. So u is equal to 0, a is equal to g, h is equal to u square sin square theta by 2g, t is equal to td. Substituting these values in the relation s is equal to ut plus half a t square. Substituting these values in the relation s is equal to ut plus half a t square, we get capital H is equal to 0 into t plus half gt, half g into td square, half g into td square. So capital H is u square sin square theta by 2g. So that is equal to half g td square. 2 gets cancelled. So td square is equal to u square sin square theta by g square. Td square is equal to u square sin square theta by g square. Therefore td is equal to u sin theta by g. Td is equal to u sin theta by g. Time of flight. Time of flight. It is the time for which the body is in air. It is the time for which the body is in air, which is equal to time of ascent plus time of descent. So time of flight capital T is equal to TA plus TD, time of ascent plus time of descent. So that will be equal to 2u sin theta by g. 2u sin theta by g. We can also derive this relation by considering vertical displacement as 0. U as u sin theta, vertical component of velocity, acceleration a is equal to minus g, and sy, vertical displacement is 0 and t is equal to capital T. Using these values, substituting these values in the relation s is equal to ut plus half a t square, we get 0 is equal to u sin theta into capital T minus half g t square, minus half g t square, or gt square is equal to 2u sin theta into t. T gets cancelled, therefore t is equal to 2u sin theta by g. T is equal to 2u sin theta by g.